You know that for the toss of two coins, there will be total four outcomes. That is for first toss, there are two outcomes. Second also two. So there are two into two. That is total outcome is four. Okay. So for first toss, the possibility are head or tail. So for first toss, the possibility is head or tail. So we write this outcome head or tail at the end of each branch. And in the first toss, the getting probability of getting head is, what is the probability of getting head in the first toss?
1/2.
1/2.
On by 2. Similarly, in the first toss, okay, getting a tail is on by 2. Okay. In a similar way, a second toss also, the possibility is head or tail. Suppose in the first toss we got head, then second toss it will be either head or tail. So possibility is head or tail. Suppose we got in the first toss tail, then second toss it may be head or tail. This is head or tail. So this is the tree diagram of tossing a two coins, and then again the second toss of getting head, the probability is half. Getting tail probability is half. Getting head half, and this is also half. If you can write the set of all outcomes from this T diagram, and then you can find the probability for each outcome. So first outcomes here, head, next head, tail. So we write these outcomes using this T diagram. So head, tail, then tail, head, and then tail, tail. So there are four outcomes. And getting head, the probability of this outcome, probability head is half into half. Half into half, that is 1 by 4. Similarly, probability of getting head, tail, this is half into half. This is also 1 by 4. Probability of tail, head, 1 by 4. And probability of tail, tail, this is also 1 by 4.
So,
Yes.
so can you once again explain the tree diagram, because outcome is clear, but the tree means the diagram is not clear, sir.
Okay. Uh, so we are tossing two coins, right? So we see in the first toss. In the first toss, what are the possibilities? Head or tail?
Yes, sir.
Okay. Yes. So head or tail. So in first toss, there are two branches, head or tail, right? Up to this, head or tail. So in the second toss also there are two possibilities, head or tail. Suppose in first toss you got head. So then head also will have two branches, that is either head or tail. Okay. Then this outcome will be head or head tail. This first two, head or head tail. Okay. And suppose you in the first toss you got tail. Then second toss there will be also two possibilities, head or tail. That is T also having two branches, head or tail. This. So these outcomes are tail head and tail tail, like this. Okay, I will draw the T diagram for three coins. Tossing three coins. So again, tossing three coins, there will be total. How many outcomes will be there for tossing three coins?
8.
8.
2 to the power 3.
Yes, 2 to the power 3, 8. So in fast toss, this possibility are what are the possibility in the fast toss?
Sir, header.
Yes, head or tail. So we write here head or tail. Okay, this is for fast toss. Okay, then we think about the second toss. And second toss again the possibility are head or tail, right? So suppose we got in the first toss head, then in second toss the possibility is head or tail. Okay, and suppose in first toss we got tail, in second toss again the possibility is head or tail. So this is up to the second toss. Now we are tossing 3 coins. So for third toss we have to also see for third toss also. So for third toss, suppose in first two toss we got head. So in third toss it may be again head or tail. This is head or tail. Suppose we got in first and first toss head and second toss tail. And again the third toss the possibility is head or tail. So like this, head or tail again for this head, and this is head or tail. This is for third toss. Is it clear now?
Yes, sir.
Okay. Actually, in chapter 2.1, we have to find only this set of all outcomes. No need to find the probability in chapter 2.1. Okay. So if you write set of all outcomes using this T diagram, then you can easily write using this T diagram. So this is head, first outcome, then head, tail. Okay. And then head, head, then head, tail, and then tail, head, and tail, tail, and then tail, head, T. So I am writing this by seeing this T diagram. Okay. So there are total 8 outcomes.
So,
Yes.
so what about if the random experiment has been done with that all the dice? So then how we will draw the tree diagram of that? So of that
Okay.
of the dice.
So for the dice also same. Okay. That is 1, 2, 3, 4, 5, 6.
Means one probability will that of those means six outcome will be there, no?
Yes. 6 outcomes will be there for
Okay,
this
so
dice.
okay, so got it, sir.
Okay. That is for then for one dice this will be 1, 2, 3, 4, 5, 6 like this. Okay. If you for 2 dice again for 1 we'll have 6 branch again. 1, 2, 3, 4, 5, 6. Okay. Like this. So you can draw also for 1 dice, 2 dice. Now see this problem, question number 2 of 2.1. In this question, you have to find only the outcomes for the various events. So the question is, suppose that vehicles taking a particular free exit, actually there are 3 vehicles. Suppose that 3 vehicles taking a particular freeway exit can turn right, turn left, or go straight. Consider observing the direction for each of 3 successive vehicles. Hmm. So there are 3 vehicles, and they can turn right, turn left, or go straight. So there are three possibilities for each of three vehicles. And suppose we are observing the direction for each of the three vehicles, and then uh, first is list all outcomes in the event A that all three vehicles go in the same direction. Okay. So if it is turned right, then we denote it by R, and for left it is L, and for straight it is S. Okay. So for this question is not asking for the set of all outcomes, but in exam they can ask for set of all outcomes. So if you want to write the set of all outcomes, then you can take the help of tree diagram. Then you can easily write the set of all outcomes. So what are the total number of outcomes? That is the number of outcomes. Total number of outcomes.
It's
8.
9.
There are total three vehicles and they have three possibilities.
9.
9. Is it 27?
27, yes, 27. 3 into 3 into 3. Okay, let's solve this question. To find on question number. So here, number of vehicles is 3, and 3 can go either left or straight or right. There are three possibilities. Okay. So total outcomes. Total number of outcomes is, for first vehicle it is 3, for second also 3, for third also 3. So 3 to the power 3, that is 27. Now if you want to draw this tree diagram for this, so for the first vehicle there are three possibilities, right? Left, straight, or right. This is for first vehicle. Okay. So for second also there are three possibilities, left, straight, or right. Straight on right, on right. So for third vehicle also there are three possibilities. So left, straight, or right. Right. Okay, so this is the tree diagram for this experiment. So set of all outcomes, that is sample space S, you can write from here. So first is LLL, then LLS, then LLR. Okay. Then LSL, LSR, sorry, LSS, and LSR. Okay. Then L, R, L, LRS, and LRR. I'm writing this by using this T diagram. Okay. Next, S S L R S L sorry S L S S L L.
SLL.
Yes, S L L, then S L R A S, and then S L R. Okay. Similarly, S S L S S S S S R, and then S R L S R S and S R R. Okay. And then for R again, R L L R L S R L R and R S L R S S R S R, and then R R L R R S and R R R. So these are the 27 outcomes. So if you try to write this set of all outcomes without taking the help of T diagram, then you have to spend more times. Okay. But if you take this help of T diagram, then you can easily write this set of all outcomes. For the first part, of this question number 2 is list all outcomes in the event A such that all three vehicles go in the same direction. That is, three vehicles go in the same direction. List all outcomes, not probability, list only outcomes. Okay. So list all outcomes in the event A that all three vehicles go in the same direction. So what are the outcomes in A?
LLL,
Yes. Okay, so there are three possibilities, left, right, or straight. So three in the same direction means the only possibility is here R, R, L, 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 and S, S, S. That is either all three vehicles turn right or three vehicles turn left, all three go straight. So the three possibilities are there. Next part B. List all outcomes in the event B that all three vehicles take different directions. All three take different directions. So what are the outcomes in event B?
RLS, SRL, and LSR.
Only three.
So RSL, RLS, and
Okay.
Sir, six
Sir,
vehicles.
LSR, LRS, SRL, SLR, uh, RLS,
Yes, there will be
RSL.
six outcomes. Yes. So if you were not
These six outcomes.
okay, so if you not confirm the what will be the total outcomes, then you can take the help of this T diagram, that is set of all outcomes here, and see the what are the three different direction. So for three different direction, the possibility here is this is you can see here ALSR, three are different here, then ALRS, okay, and then here SLR and SRL, okay. And similarly here, which is RSL and RLS. So total 6 outcomes are there. Okay, you can take the help of this tree diagram, otherwise you can write also by yourself by thinking that suppose first is L, so remaining is right or state. So suppose RS and RS also can interchange. So L S R 2. Suppose first is straight, then remaining 2 is L or R. So LR also can interchange. So this is S R L. Suppose first is go so okay, turn right. So remaining is ALS. So ALS also can interchange. So RSL. These are the total 6 outcomes in the event B. And C, list all outcomes in the event C. List all outcomes in the event C that exactly 2 of the 3 vehicles stand right. Exactly.
Sir, couldn't hear the question.
Huh?
Sir, couldn't hear the question.
So can you repeat the question, sir?
Am I repeating now? So list all outcomes in the event. I'm writing here. Then you can easily answer. Let's see. Exactly two of the 3 vehicles. Three vehicles take different directions.
Sir, 18 will.
Okay, sorry. Here exactly 2 of the 3 vehicles uh, turn right only here. In part C, only turn right. Okay. Part D, 3 different directions will be there. So part C, exactly 2 of 3 vehicles turn right.
2 wheels.
Turn right. So total number of vehicles is 3. So out of 3, only 2 vehicles, exactly two turn right. Then what are the outcomes in this event C?
RLR, RSR.
Only 2.
So RRL, RRS,
So there are 6.
RSR, R, RLR.
The total, how many are
The
total?
total 6.
6.
8.
6. Total, there will be 6.
Yes, sir.
So if you are unable to write, then you can take this help of this total number of outcomes. That is from the sample space, you can easily write by seeing where is that exactly 2 are. Okay. So exactly 2 of the 3 vehicles turn right. Suppose the first 2 is turn right. Then third may be left or straight. So RRL or RRS. Okay. Also, we can interchange this LRR and RRS. That is like for first outcomes, it may also possible that LRR. Okay. And for RRS, also possibly only other possibility is SRR. Okay. Also, we can place this L in between 2R, that is RLR. And also for RRS, RSR. So these are the possibilities. There are 6 outcomes in the event C. Now D, or D is all outcomes that exactly list all outcomes in the event D that exactly two vehicles go in the same direction. So what is total number of outcomes in D? What is the total number of outcomes in D?
9.
No, 18. So two vehicles go in the same direction. So same directions may be right or maybe L or go straight. Same direction may be S also. So for right, we have already seen in part C that if exactly two of the three vehicles turn right, then there are 6 outcomes. So similarly for straight, there will be 6 outcomes, and for left also there will be 6 outcomes. The total 18 outcomes. Okay. It is can write here exactly 2 in R plus exactly 2 in left plus exactly 2 in straight. Okay. So for these three possibilities, you can write, you can list this set of all outcomes. So for R, we have already seen that R is for two exactly 2 in right. So R S, then R L, then S R, and L R, and then R S R, and R L R. Okay. Similarly for exactly 2 in left, L S, L R, and then S L R L, and then S L, and L. Similarly, exactly 2 in straight, so this is S L, S R, then S, and S, and SL S, and S. Total 18. Then part E, list all outcomes in D complement. So find D complement. You find D complement, D dash. Okay. And then list of all outcomes in C union D and C intersection D. So find this D complement first. If D is this, they list all outcomes in the event D that exactly two vehicles go in the same direction. So event D means exactly two vehicles go in the same direction. Then what will be the complementary event D complement? Can you write anyone?
Sir, L.
Okay, what will be the total number of outcomes in D complement?
Sir, 9.
9. Yes. Because in D, total number of outcomes is 18 and total outcomes in the sample space is 27. 27. So D complement means just remove this D, these outcomes which are present in D, remove from S. Then the remaining is only 9 outcomes is there. So total outcomes in D complement will be 9. Okay, so except these outcomes in D, just write the remaining outcomes from S. Otherwise, you can think like this, that D means exactly 2 in the same direction. Okay, D means exactly two vehicles go in the same direction. So D complement will be either three vehicles go in the same direction, or or they go in the different direction. The complementary event of D. So exactly two, the complementary of this exactly two is either exactly three go in the same direction or three goes in the different direction. So the outcomes in D complement will be either all three in the same direction, or they go in different direction. So D complement means either all three go in the same direction or they go in the different direction. So we have already found this, the three go in the same direction, the outcomes, and for three go in the different direction, the outcomes is here. That is A. All three vehicles go in the same direction. The event A, and B means all three take the different directions. So actually D complement means A union B. See this? A union B. D complement means. Then you can find the union of these two sets A and B. Then for three go in the same direction, the outcomes are R, 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 L, 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 and S, S, S. And for different direction, and this is you can write directly from this event B. Okay, B event, that is L, R, S, and L, S, R, and S, R, L, and S, L, R, and R, L, S, and R, S, L. Total now 9. So also find C union D and C intersection D. Also you have to find C union D and C intersection D. Okay. What is C and D? See here. C means this exactly two of the three vehicles turn right. C means exactly two of three vehicles turn right. And D means list all exactly three vehicles. Exactly two vehicles go in the same direction. That is D. And C means exactly two vehicles go in the two vehicles turn right. That is event C. So you have to find the union of C and D and intersection of C and D.
Sir, union will be D and intersection will be C.
C, yes. Because this C, the event C is subset of the event D. You can see here. C is subset of D. All the outcomes of C is already contained in D. So actually C is subset of D. So since C is subset of D, C union D will be D and C intersection D will be C. Done. Ranjari Pushkar, please use your microphone. 957. Okay, see the next question. Question number 4. Each of a sample of 4 mortgages is classified as fixed rate or variable rate. Okay. So total number of mortgages here is 4 and is having a possibility to be fixed rate F and variable rate V. Then what are the 16 outcomes in S in the sample space? Then you have to find these remaining probabilities in part B, part C and part D. Okay. Question number 4 of 2.1. So here number of mortgages, this is 4 and 4 mortgages classified as fixed rate or variable rate. There are two possibilities, either it is fixed rate for F and for variable rate V. Okay. So for first mortgage, this possibility is 2, fixed or variable. For second also 2, for third also 2, and for fourth also 2. So this is 16 total number of outcomes is 16. Okay. So draw this T diagram for this experiment. So there are 4 mortgages for the first. The possibility is fixed or variable. For second also, the possibility is fixed or variable. So for third also fixed or variable. Okay. For fourth also the possibility is fixed or variable. So if we so this is the T diagram. Okay. So from here you can easily write this total number of outcomes, that is 16. So here from this T diagram F F F, okay, then F F F V, then F F V F F F V V, then F V F F F V F V, then F V V F F V V V, and again a V F F F and V F F V and V F V F and V F V V and then V V F F and V V F V
and then VF, and 4 are variable let. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Total 16 outcomes. So the first part is what are the 16 outcomes in the sample space? So this is a sample space. This is part A instead of part A. List all outcomes in the sample space S. Okay. Next, part B. Part B. List all outcomes in the event A. List all outcomes in the event A that exactly 3 of the selected mortgages are fixed rate. Exactly 3 are fixed rate. So what are the outcomes in A then? There are total 4 mortgages are there, and so out of these 4, what are the
Sir,
outcomes that?
AFF VF, if VFF and V triple F.
Uh, 4. Okay, that is exactly 3 are fixed rate. You can write using this so total outcomes in S. That is where 3 fixed rate means F. 3F is present. So okay. So exactly 3F. Okay. So this is one possibility exactly 3F, and this is another possibility exactly 3F, and this is another possibility exactly 3F, and on another possibility is this exactly 3F. Okay. So the outcomes is FFV, and then FFVF, and then FVFF, and then VFF. There are 4 outcomes in A that exactly 3 are fixed rate. Similarly, B, list all outcomes in the event B that all 4 mortgages are the same type, All 4 are same types. So what are the outcomes then in B?
So FFFF and VBVB.
Yes,
Wow.
4 are fixed rate or 4 are variable rate. The 2 possibilities. Then D, list all outcomes in the event C. List all outcomes in the event C that at most one of the 4 mortgages is a variable rate. At most variable rate. So at most one is variable rate.
Sir, 4. Sir,
Only 4.
4. Sir, 4 it's coming. FFFV, FFVF, FVFF and V triple F, that one.
Another possibility is there. Can you find that? Total outcome will be 5.
FFFF.
Yes. F. At most one means uh, either no variable date. At most one means no variable dot or exactly one variable date. Okay. So at most one means either no variable date or exactly one variable date. That is the meaning of at most one. Okay. So no variable date means this outcomes F, and one variable date means like F V or V F and F V F and F V F. So at most one means either exactly one or no variable date. Okay, so no variable date for this, and exactly one means this 4. So total 5 outcomes in the event C. Okay. Then part E of this question, part E, what is the union of the events in part C and part D? Okay, so we have to find the union of the events in part C and part D, and what is the intersection of these two events. Okay, see what are the events in part C and part D. Part C and part D means this B and C. Okay, B and C. So you have to find the union of B and C and intersection of B and C. So you can find this B union C and B intersection C. B intersection C means only the common outcomes in B and C is this only F 4F. So B intersection C is 4F here. Similarly, in part F, what are the union and intersection of the two events in parts B and part C? So part B, you have to find the union and intersection of part B and part C. So part B means A and part C means B. So you have to find A union B and A intersection B. A union B and A intersection B. So here in A and B, they have no common points in the event A and B. So A intersection B equals to 5. So some other problems I have solved here, that is question number number 6. And also question number 5. Okay. So I'm going to upload this PDF file in Google Classroom. You can download it from there and then go through all these problems. In next class, we will discuss, that is, we solve problems from the exercise 2.2. So I'm taking attendance, roll number 101,
Present, sir.
119,
Present, sir.
then 148,
Present, sir.
165, 165, 168,
Present, sir.
or 205, 207,
Sir, 205 present.
Okay, 207,
Present, sir.
213,
Present, sir.
227, 229,
Present, sir.
227 present.
okay, 294,
Sir, 127, I think you missed or I couldn't hear. 127 present.
294 present, sir.
just wait.
Oh, sorry, sir, 142, sir.
318, 318, 320,
Present, sir.
353,
Present, sir. Sir, 318 present.
okay, 479,
Present, sir.
491,
Present, sir.
567, 575,
567
Yes,
present.
sir.
575 present, sir.
651, 660,
Present, sir.
678, 798, 809, 811,
Present, sir.
809 present.
okay, 814, 815, 817,